So welcome. We have our webinar today. Glad you could join us. If you would like to support future AMATYC webinars, please consider becoming a member of AMATYC. Our sponsor for this year is McGraw-Hill Higher Education. AMATYC offers a variety of professional development opportunities and publications, from the AMATYC News to the My AMATYC website. Our next annual conference is in November of 2025 in Reno. We also have several AMATYC social media sites. Ready to be the next AMATYC webinar presenter? Have a great idea and are ready to share? Use that QR code to submit your webinar proposal. We have recordings of previous webinars on our AMATYC webinars web archives page. Please do allow up to 2 weeks for production and upload of the recorded webinar to the archive. The views expressed by the presenters are not necessarily the views of AMATYC. Commercial products mentioned by presenters are not endorsed by AMATYC. So today we have, should we always simplify answers? It's a great question, especially with the end of the semester fast approaching us. We have Tuyetdong and Michael Todd. And today you can see here, you've seen them already as they're both visually on your Zoom. And this is just a little bit of a bio for each. So Tuyetdong enjoys graphical illustrations with GeoGebra, integrated that into her teaching. Mathematic educator. Todd Edwards is a professor, education with focus on preparing future educators, and several co-edits. He also has used GeoGebra, so perhaps we'll see some today. Webinar attendee survey. I will put this link in the chat for you to complete. I will also send a follow-up email, so if you don't get that or complete that, no worries. I will make sure to send that to you. So again, it's definitely a nice way for us to all share, discuss, and to learn. So I'm going to go ahead and stop sharing, and I'm going to let Tuyetdong take over. Whenever you're ready.
Yes, I'm ready. Okay.
Sweet.
Let's see. What does it go?
You're doing good.
Okay. Can you see my screen now, right?
Yes.
See my screen? Okay. Okay, so here my thank you, Mari, for introducing us, and thank you for AMATYC let us to have this opportunity. So again, you hear a short prep of my bio. So my name is Tuyetdong Phan-Yamada. I am a lecturer at Cal State Los Angeles in California. I published several papers on AMATYC and really like the way that they work with my paper. Very nice, easy. And you may wonder, how do Michael and I, yeah, because like Michael and I, we both work on GeoGebra, and Michael helped me on other paper with GeoGebra too. So that's why I invite him to write the paper with me. So I let him introduce him a bit.
Hello. This is my first rodeo with AMATYC, and I can't tell you how thrilled I am and nervous at the same time. I appreciate the opportunity to talk to you a little bit about simplifying answers. It's really a topic near and dear to my heart. So thank you for letting me be a part of this, Tuyet.
Thank you. So you guys see this picture right here is I created with GeoGebra, and then you're gonna see some of this on our talk today. So we're gonna begin this one with a poll. So which best describe your policy regarding students simplifying answer? A, I require student always simplify, and I sometimes require students to simplify, but not always, and never insist that my students simplify the answer. So can you take the polls, and then we'll show the result.
I launched the poll, so please complete the poll. Once the poll is completed by all attendees, we have 28 attendees. So hopefully everyone is going to participate. It might be because I don't participate, so yeah. All right, I'm gonna go ahead and end the poll and share the results.
Yay. So thank you for sharing. So we have like most people were required to simplify, but not always. So we have the reason like that. Sometimes simplify means something because it's help the purpose. So I'm gonna start with our thing right here. Yes, you are right. Many times that we have to do this. So let's start with quadratic equations, and we know all the time the equation that they can solve the other methods that they can use the quadratic formula, and they come up with like this, and we make them simplify all the way this over here. So that is sometimes it help us to help us to explain to them easier. So the one right here would be our the axis of symmetry right here, right? And then the radical 2 is how far is the distance from the x-intercept with the axis symmetry to the 0. So that's what it helps us. So a purpose for us to see, that's why we want student maybe stop over there, and maybe we don't want them to give the answer, the actual number, like, this one would be negative 0 point something, 2 point something. Maybe we didn't want to do that. And then, so, however, this requirement not always. So let's take a look at this one right here. So I have a length of rectangular garden in 10-meter long, then its width, its area 125, and the width of garden. So hopefully our student will do something like this, come up with the equation and come up with this, solve for this, and they simplify all the way to over here. However, we hope that our students see that, oh, this is negative. So the negative would be, doesn't work because we need a positive answer. So hopefully they see that way. But then actually, how long is this thing like negative 5 plus 5 radical 6? How much is that? How long is that? Let's take it back. Instead of simplify all the way to the end, we're going to start from right here, right? So we think is square root of 600 right here. It's very close to 625, which is radical which is the answer would be 25. And then, so this approximation would be 7.5. This one, if you put this number into the calculator, it'll give us the number like this, 725. It's very close. So I think for this question for me, I would tell my student, don't bother to simplify. Don't even do anything over here. Just stop right here. And maybe the answer, I would like my student to, I always pause my student right here. I would ask them like, which one do you choose? You have 2 answers. So do we have 2 answers? And some of them will say, okay, so I want this one would be the negative doesn't work. So get positive only. So hopefully they just see this one right here. And then I pause them right here. I ask them, so can you give me the approximate number? So my student can, some of them can say, but help the other to see things. As for them to see that not you don't have to simplify all the time. So therefore, for me on the question like this, I would have my student, you have calculator using, you don't have to rationalize and put into the calculator. You don't have to do that. So I told my student that's it. Yeah. And then this is thinking about this question. I have my student to practice this to recognize, number sense, to see like which number. So I asked them to see which one positive. So most of them would choose this one because, 8 minus 6. So I want to see that way. And very hard to see because there's radical 2 here, not friendly. Yeah, and also radical 3 right here. I will see that. But actually, this question is from this one that when we ask students like, rationalize, simplify this one, take off of this thing right here. With that, we ask students do to get the part A. I don't know why we have to do that, because this one here, when students see like this, they can see the answer better because, 8 is radical 64. And they say, oh, compare these two. So this one, it could be negative because 64 less than 72. And so also this one right here. However, you ask them to do A would be harder. So therefore, any the questions I kind of opt out this one here. I like my student leave the answer like this and tell me positive or negative. I don't know, but we have a lot of questions like this on the homework. We make student like, rationalize, do this here, take it out and do everything. So other than the purpose that we see from beginning, I like to leave this one on the part over here. I don't know what you guys think, but maybe you guys can give me some comment on about this one. But I like to see this one in this way. I don't know if we have question on the chat to ask. I think I saw something flash on. I couldn't see from my thing. So, do we have any question on the chat?
No questions right now.
No question. Yeah. Okay. So the next one I have Todd will introduce this one to you.
Okay. Hey, Tuyet, do you mind could I share my screen so I can control the? Do you care if I do that?
Yeah. No. You do that easier, I think. Yeah.
I don't know if it's easier, but okay. Let's see if this works. So I'm assuming that you see the screen, correct?
Yes.
Yeah.
Okay. Something that really jumps out at, I need to say this quickly before we get into this slide. Is the fact that what Tuyet's talking about reminds me a heck of a lot about estimating and number sense. And I think it's true in the case of my students, they tend to want to get an answer more than anything. And when you ask them to estimate an answer, they really struggle with that. They're so used to following these lockstep procedures. I think that kind of gets in the way of number sense. And the examples you just shared, Tuyet, so much easier to see like the square root of 81 minus 72, if it's positive or not, right? We really want to get our students thinking more about number sense and be less concerned about always the final answer is the only thing that matters, right? It's about understanding. So I have a slide here. It says, should we always rationalize? And in this case, we have a trigonometric example. And so, sine of 45, typically kids are told to rationalize the denominator. So we have an integer in the denominator rather than the square root of 2. And historically, this was important to do this for a couple of reasons. The one that I'd always heard of as a high school teacher was that back in the day, people had to look up these numbers in a table. In fact, when I was in high school, we still had to do that. We had trig tables in the back of our textbook, and the values weren't listed with irrational numbers in the denominator. So it was helpful in that way. Now, many of you said that you sometimes have students simplify and sometimes not. I guess I'm kind of curious, when wouldn't you? I guess we can have that as a rhetorical question, but if you put that in the chat, like what are some reasons you've heard of for rationalizing the denominator, or simplifying? Like, when do you have your students simplify? What were the reasons for doing that? Is it primarily historical? Is it just a habit? Is it actually help your students? That's kind of a question I have. If you look, I will not wait for your response, I suppose, but look at the next slide.
I think let read some of them. I think some of them.
Yeah. Please read some
really
out loud.
good. So let me read it for you. See here.
Yeah.
Simplified because require textbook answer because mathematician is picky or picky. I think I'm good. I heard that's one. Combine a term at cent for simplified. So you can see that's one over there. Practice factoring. Yeah. Simplify help us able to combine like term and see if the answer perhaps integer. Yes, that's true, Paul. I agree with that. So that's why you require students to simplify all the way up, huh? And if you add side 45 and go side 30, it helps to rational denominators to add. And
Yes.
Peter say, I have my student not simplify at first. When they do a probability problem to get correct, unsimplify that show their understanding, and then to simplify in a way that optimize their communication. Thank you for sharing. Yeah, I agree that, we simplify so that we can combine like term, which we have to do later. But I have question for you after Todd say this one. Okay.
Okay. Hey, by the way, I appreciate your posting some things in the chat. I really like the interactivity. That's kind of keeps me going. Otherwise, I get nervous. Like, what are people thinking? So this was the main rationale I used to give my students. It was largely historical. I really like the comment that it matches the answers in the back of the text. Because a lot of our students, especially those in remedial courses, it's helpful to have the answers in the back and know that we're on the right track. And if the answers aren't listed in the back of the book, unrationalized, or in different forms, then that's going to cause some concern for the students. But that leads me to believe that, like McGraw-Hill, the sponsor of this webinar, maybe we should consider having non-simplified answers in the back of the book, to better support our students. Another reason for historically for rationalizing was simplifying for manual calculations, like Tuyet said, and a couple of you have said, to add fractions together, for instance, having those like denominators were helpful, right? Thirdly, you mentioned this too, largely aesthetic. I think we're picky. For some reason, we're told that it's more beautiful when that radical 2 is on top, and we buy into that. Students don't buy into that as much as we do. Maybe we should listen to our students. It's okay. Just as elegant to have that square root of 2 on the bottom, in my opinion. Here's an example of why conceptually it might be better for us not to simplify. Just the whole relationship between cosecant and sine, like seeing that these are actually a reciprocal relationship, is easier when you don't simplify. Here's another example from trigonometry. It might be better to not simplify the tangent and cotangent, so we can see its relationship more easily as well. I'm just a fan of really thinking more critically about whether or not we simplify. If it helps the student and their understanding, I would say yes. If it doesn't, I would say that's an artifact of the past that we need to let go of. Yeah, that's the end of my presentation.
Thank you. I will continue. Yeah, so yeah, thank you. Yeah, I agree with some of you say on that part that yes, we do. Sometimes we rationalize, and sometimes it's make it easier for to see things. But I still see thinking like, why do we have to combine like term with all the radical and rational? So maybe you help me something that later. I couldn't see the chat right now because I'm sharing screen. So one of the things we do, we show students, sometimes we need to simplify, sometimes we not. So this question from calculus, so find critical value of this function right here. So when you have this one here, you pick, yes.
You're not sharing right now.
Oh, I'm not sharing. I'm sorry.
No, ma'am. It's okay.
I thought I did. Sorry.
It's okay. That's why I'm here.
Okay. Thank you. Thank you.
Yay. There you go.
Okay. So let me go back. Okay. So this is the slide that we have in here. Okay. So for this one, this question right here is from calculus. So we asked them to find the critical value. And then we have this one have the derivative. So they have here. So on here, and I think in calculus, we didn't tell students, oh, rationalize this one, we have to get rid of the radical on the bottom. We didn't tell them that. We just like, okay, so find this. And then we could do, the top, the bottom, because this one, when you get rid of the bottom, you make the question is more, it doesn't look simplified to me. So one time I have a student ask that, say, Miss, it says simplified, but it looked like we write it longer than it's supposed to be. But we have something like this. We mentioned student, sometime I told my student all the time, when you were in lower class elementary school, then your teacher will tell you do this, do that. But when you into this level, you're in college right now, so you will say, you have to make decision what you do. I like the comment somebody I say earlier, talk about your Algebra 2 student, you whisper to tell them, okay, sometimes you don't have to, but don't tell Algebra 1 student. So that they have to learn all the skills, but then I think in college algebra, they should know that it's okay, like you don't have to simplify all the time. And sometimes it's helpful. Let me go to this one here. Here is the question from probability statistics. So I got this one on the website when I searched for it. I'm just curious to see how people think about simplify or not simplify. So I run into this question. So the question is about you can see right here, here's some information about 50 people who took a driving test. So 18 of 50 people are teenagers. And a quarter of adults failed the driving test. The number of adults who passed in the driving test were 8 more than the number of teenagers who passed the test. So a percentage to random, what is the probability that they pass the driving test? So the student should work like this. So the person who posts on this one, is say his student posts like this and didn't get full credit because he didn't simplify. At first he said, yeah, you have to simplify, but he thinking back and say, why do you have to simplify? So this one, it have, the answer say that you have to simplify to this instead. So this one, it have the long discussion on this website here. You can look it for yourself, and maybe you can put your reasoning on that one. So I thought that's really interesting. But to me, one of people mentioned that, probability, you have to live in fraction. I say, well, when we say probability, do you say more like percentage than fraction, right? So you would like to say 20% more than, the fraction 1/5. It's kind of hard for people to visualize that way. So to me, I don't simplify, but I'm going to make it 100, so I can multiply by 2. Top to bottom. So I will have that percentage here. So you tell students, sometimes you don't have to simplify, but sometimes you make it number bigger into the thing that you want people to see. People understand 80%, I think, better than 4/5 in general. Is again, I show my student on statistics, but I do say if they have 0/5, then I want the answer to be 0. I don't want them to live like that. But the other part, they can leave it. I'm okay with that. So for those of you who teach statistics probability, can you give us some opinion about this? I couldn't see the chat. So Todd, can you read something and maybe comment about this one?
Oh, yes. I mean, there are all kinds of great comments in the chat. I was just commenting on what Lee said earlier about simplifying Hyde's structure. Peter mentioned the probability example earlier. Paul Seberg had some interesting things to say about, it's not always or never, we need to think about when. Let's see here. That's some of the things that jump out at me. Chris Ward had some things to say. I generally have them use decimal form to get p-value concepts later on. That's a good point. In stats class, Noah Weiss says, in my stats classes for probabilities, I usually want them to give a decimal form, but to show their work with fractions, not requiring reduction to lowest terms. So, I think that covers it. You can go on. Thank you for thanks for everyone for talking in the chat.
Yeah, I agree. So I don't ask my my statistics student to reduce to the lower form. I just, okay, you have that and give me the decimal. And somebody mentioned that, if online question put in there, so, let the computer figure out is a yes or no. Yeah, for that part. And so we move on to, okay, so now before we move on to the next section, so we have another poll right here. So Mary, could you please help us in this one here? So how often did you have your student explore the topic before you teaching this? Just to one, yeah.
I'm just kind of letting everybody answer.
Yeah, thank you.
Mary, I greatly appreciate your presence.
Oh, I'm a presence of calm is what I like to
You
say.
are. Oh my gosh.
I've learned that it's all good because you never know what's going to happen. Technology and
That's
all
right.
the things. So it's all good. I'll give it just a couple more seconds. Okay. And here we go. So you should see it now.
Oh, they're very good. So we have the people do a couple of times per semester. I think same thing too, because we don't have time to do much, but like something main topic. So I would like to have my student to explore the concept. I told them they nervous. They just say, oh, I might get wrong answer or something. But I say, no, they should just explore the concept, just do to see what we find out, and then we learn later. But I found that student kind of, because they have the habit of simplify everything, so explore the concept, it kind of it's hard for them. So here is the thing that I had my student to do. Thank you, Todd, for have this quote right here. So they said on this one here, the research say that when students are given opportunities to explore the pattern without pressure to simplify, they develop a stronger conceptual understanding and are better able to transfer their knowledge to the new situation. I really like this one, and I think it's true. So have my student to see, okay, messy work, whatever that happened there. So don't bother to simplify, and you find something new. So this is one of the example to back up for this research right here. So I have my my calculus student before they do Siri, like learning about Siri, I have them do this here. So this the animation I have it on my my website, so I can give to you later. So I asked them to find the total area of the white triangle right here. So first, everybody can look at here. They can say 1/4, no problem. The next one, they can do this, and then many of them try to simplify, give me a number over here. I let them go, okay. But many of them try to do that part, try to, combine the fraction and give me the number instead of give me the expression like this. But then they go here, and then they go this one here. They did like, they give up. They don't do that. So I told them, okay, go back to do this one here. And I give them some hints before I move to the next table. I say, well, let's see, can you rewrite that 3? You see, how do you get 16? And then so they explain, oh, this one like a 4 of a 4. So you can, so you can write it 4 square, and then you count how many of them here, 3. So with that hints, so they be able to do the next one. And when they see like this, they can go all the way to the end, to the figure end. So again, this one, if we combine, we do common denominator, we do other thing, we get a number, one solid fraction. It couldn't help students to see the pattern 4 to 5, this one right here with G for the series. And then I tell my student again, so when you were, in the lower grade, yes, the teacher, the textbook tell you to simplify, give me a solid number, decimal, if you could, but that decimal, it couldn't help us to figure out this one here. This this is many of you know this pattern in here, right? So that's the one that I have earlier. So you see that flashing on my intro slide. I have this one here, so you can have that later. Now we have here compound interest. So I think starting algebra, we throw a student the formula of compound interest, And we say, here, do it. We didn't explain until calculus when they learn theory, and then they would do this one. But however, as a concept, it kind of not easy to see. So I found this question on active calculus. So here the question go, I think that number messier than mine. That question over here like 500 and this one 8%. So I could change it to 1012%. So help my student, easier to do. So I told them, okay, 1012% annually. That means if you divide by 12, so 1% per month. So make it easier for them to calculation. So active calculus, they had the student do answer the question right here. I really like the idea. So they have the students, so I summarize it right here. They have students to compute like 12 months, see how much they have in here. With the hope that the student will find the formula. So I found that's really hard to do because you look at all this number, how do you find formula for this, this decimal number here? To me, I don't see it. Maybe some of you help me later, but I think this one is really hard for me to see. However, I told my student, don't simplify, do this. So 1,000, so they give me 10. So I say, where do you get 10 from? Oh, they told me this. So I say, just leave like this. And this one, I say, oh, so now if you add the initial balance plus the interest, so see, both of them have 1,000, right? You factor out, so you have this. And I told them, don't simplify. So they struggle, they do all kinds of things, but at the end, so they can do this here, they found this right here. Oh, they say, oh, something pattern, huh? And I asked them, so what are these numbers? What is this one? Is there anything? So they say, oh, this number matching with the number right here. Yeah. So, and then I say, oh, so if you have 1 year, then you have 12 months. So this number kind of something. So help them to see this one, it lead them to see more general form. We would like to start this one, but because the student, somehow they didn't like letter, they like number so that they can work with. So we can give them number like this, but the end, we tell them, okay, so this one, it did like 12%, you divide by 12, so that in number of months in the year. And then this one over here, we have this part, and this here, that how many months, so that you come out with like n times t, that means t the time and then n, how many period in the year that you want to. If you do monthly, then you multiply by 12 and then so on. So this one would help the student to see the formula, how did it form. But if we let them do in active calculus, they have them do like equal to a number. They could write out a number, and I don't think the number would see the student would see, come up with the formula. It's not easy to see. To me, I don't see that. So maybe some of you have some idea, you guys can please share with me. But that's how I have my student work in this way. So again, don't simplify, leave it like this. Don't do anything to see that different. And then I move to the next one. So I have this question on GeoGebra. Let me see if I can, oh, I cannot do that. Maybe at the end, I will have this one, I give it to you, or you can email me, then I send you the link to all the question here on GeoGebra so student can practice and see things. It's a little bit messy, but I have my student, either they do on paper or on GeoGebra. I have the app for them to do. As some of you mentioned, before, I always make my student reduce, give me the lower term, we do all of that things. So, so when I prepare for this one, so one of my students, my best student in class, so he did this problem in calculus 2, and he had the answer right here. So, and when I grade this question on my open math, and his answer is wrong. So he submit the work too, because I make all of them submit the work. So his work like this. So I went through the whole thing. I said, he did everything correct. So why is wrong? And then, so so this is the answer key from my open math right here. So I have decided. So I say, why is wrong? So I went to decimal, and then I enter his number in here and say undefined. I said, huh? So is that my open math, the code question wrong or something? So, and then I go back to this one. I saw this one here. So, I said, oh yeah, because this one right here is like too big. the calculator cannot hold this one. So I tried a couple of them. A handheld calculator, GeoGebra, they all say undefined. It doesn't work. Nothing wrong with this, but because the number is too big, 50 to the 2000 something, and then you divide this one right here. So it's too big. It cannot hold it. So I put these number into decimal. It gives me the number right here. So you see the number is almost go to here. If I make it more decimal, we go the whole thing right here. So my student get penalty because he listened to his teacher before. You have to simplify, you have to combine, you have to do everything right here. And he got marked wrong. Of course, I give him the whole credit. And I told him, I say, okay, so I show him like, go to decimal, put this number in, and you see the answer in there. So maybe you have that good habit when you were, in lower grade, you get trained well, you make sure you always simplify, do everything. Instead of writing the long thing here, make this one, it look shorter. But actually, the calculator cannot compute that one. I learned too. So since that day, I definitely on my calculus, you test some concept, how to take integral of this one, leave the reduced thing to the lower grade. So as some of you mentioned before, if they put in here, it matching with doesn't work. In this case here, his simplified doesn't work. So yeah, so this one here, I think somebody mentioned to me like Mathematica can handle this number, but other things on the website, it couldn't do this one. Yeah, since then, my calculus, I just say, okay, put whatever you want, but 0 divided by 5, again, you have to give me 0. You can't give me that one, but anything that, or 5 divided by 1, so you have to give me 5. But the rest of the fraction, I don't care. You just put in there as it works, that's good. So you don't have to simplify, just leave it messy. So that's what I do. So I coding on my open math too. So before I try to code to make sure that students have to answer the question in simplified thing. But right now it take a lot of my time. But I found this one, I said there's no reason because now we all use calculator. Whether or not you like it or not, people go work out there, they don't simplify they don't rationalize, they don't do the, denominator, everything computer. So we don't have to make our calculus student ding our calculus student because they didn't simplify the answer. So that's my attitude toward this one. So I don't know if any of you have something about something that you think like they still need to require. So please share. Yeah.
Yeah, there's a number of really nice comments in the chat. I'd like to shout out a couple of them at least. And these go back a ways a little bit. But Pam Coop was mentioning that she makes her students repeat fractions are our friends. A lot of people are talking about how they tend to agree that, like Paul Seberg says, not simplifying helps students see patterns. I really liked Sylvia was talking about recursive sequences, and you're able to see how the recursion works better if you don't simplify. It's a really nice example. Peter talks about fractions make the pattern more easily visible. Like a lot of people are talking about that. Leeds says, I stopped using online homework systems since they often mark items wrong if it's only written in a certain way. And, your example, some of the examples are just like that.
I'm Michael. If you look at the Q&A, there's actually a Q&A question too.
Oh,
yeah.
Where is,
so at the bottom, it'll say Q&A, just click on it.
Yeah.
It's from Sylvia. So it might be a question y'all might want to answer.
Yeah. So Sylvia says the example with the integral and the overflow and the calculator is great. With AI around us, I wonder what do you think about the value of doing integrals like that? I think the value of integrating is nurturing analytical skills, but I also believe in modeling using technology and integrating either with GeoGebra or Mathematica. So feel free. There are 3 answers up there already.
So I actually answered the previous questions. So I think this one I'm gonna let y'all kind of answer this live. So what do y'all feel about all of the AI and doing these kind of different types of so example, I think she said by integrals. So
Yeah, I think I'm really great fan of my open math, and then people they wrote many good question on that. The question that they say, what did they call internet anti-internet or something like that. I mean, they write question like, you cannot put in AI, you cannot have answer like that too. And because you can have part to do that. So I kind of copied that one. So I went to AMATYC conference a couple weeks ago. So that question like that. So I am a panelist for the writing section. So that is one attendees asked question like, what do you think about like, AI writing, anything like that? And there is one professor, he said he has a several hundred years old math textbook is really good. And he read it and he didn't understand. So he hoped that somebody can write that one to decode on the math thing on that for him. I agree with that. So AI, if you have the formula for them, then they will do everything for you. But what we do in here, mathematician, we do, if we find something new, something like, I kind of in doubt that AI can come up with formula. Something I told my student, I teach statistics this semester. So I have my student do a project I call red light reaction I wrote. So some of you may read it on the statistics journal. So that's in my, so I told my students, so can you get like, give the data that you collect and give it to AI, ask them to write a report about this experiment. See what do they say. My student didn't come out yet. So I still thinking, yes, the writing is really good. You can use AI for research, really good. But in something for, mathematical, we find the pattern, something new, something that not existed before. So I still think it not there yet. And you may concern about, student cheating while using all the online homework, everything that you punch in the number. There are people, a group of people on my open math that is really good in write out questions. Those things that you cannot have that. You don't ask students to take integral of this one. Maybe not, but maybe you require them to show work like this. My student, I told them, if you don't give me the work, then you will have no credit, even you get the correct answer. So that's how I do it. And I didn't see cheating in my class in this way because I do active learning. So in class, I teach the class, the topic, and then I have students practice right in class. So they with me, so they know, I know who they are. And then, if they have the question like come out from nowhere, no work, then no solution. So that's what I did in my class. Yeah.
Tuyet, I'd like to echo what you say about AI. It's not just, I use AI every day. It's just not there yet for doing integral calculus, right? Like,
yeah. So let's move on to the next section here. So let me go back. Okay, so I have a whole bunch of this question right here on my open math. So you can search for this question ID right here. I have that one just for fun to try that, either that question or this question. This is another one the calculator cannot do. Yeah, so these two here. So I'm gonna have you try that later. So when we do the algebra, college algebra, we have them to many questions like that, find the first 3 terms like this one right here. So we ask students to simplify, give us a number. So this one will be 1/2, this one will be 1/6, this one will be 1/12. We ask students to give this one right here. Yeah. But then we move on to series. we introduce the concept of series. So we have this one right here, it's like this. So this series, you know, this is the sum of the first n term that we have, first k term that we have in here, which the term is gonna take from here. Yeah. So we have the A1, A1 and S1 is easy. A2, so they're gonna have, okay, so this 1/2 plus 1/6, so they have here, they give the number. So we're gonna ask them to do to S3, but before do S3, it's gonna be hard for them to do S3. If we tell them to do this one, then it be able to do. So instead of write like 1/2 plus 1/6, then we have them leave it here alone like this. So 1 minus 1/2, I leave it here, and then plus 1/2 minus 1/3, we leave it here. And oh, they say, oh, these two cancel, so give me this. Yeah. So maybe let them try, now you let them try S3, so they realize that, oh, I don't have to reduce write this one in single fraction, but I can leave it alone like that, and I give the answer later, then they will see this one. We like them to see this one because later in calculus, we introduce them telescoping series. So they're gonna have something like this. So we have a lot of them like this one right here. So if we keep asking students like reduce, then they have the habit to do that one, so they don't see it much. But we introduce a little bit every day. So by the time we teach up to here, they will know that, you know, sometime we don't have to simplify. Sometimes leave it messy, it's better. We're gonna clean up at once instead of, you know, labor work for denominator and or rationalize or do all that kind of thing to have that part. So that is our kind of paper of the work on should we simplify or not? It's paper published on AMATYC too, so you can looking for our paper. We're gonna write more detail in that one. Todd have a lot of survey about pedagogy and, you know, all research say about what we found in there's a lot, but this is what we find. But I would love to hear if you can share with us some kind of problem that should we simplify or should we not simplify for the thing to share with us. Either, I don't know, Mari, that we be able to say that here, or can they email us, or how does it work?
They could put it in the chat if there was like a link or something, maybe. Or they could just email y'all directly. That's definitely an option as well.
Yeah, so please email me or Todd. Please share with us your experiences about this one, or, you know, your thought, your research, your paper about this topic. So we would love to hear more about this one. I would like to learn to show my student in my teaching. So thank you so much. I don't know, is there any question for us to answer?
I don't have any in the Q&A, unless someone wants to ask a question.
Can I hold this so I can see the chat?
Yeah, sure. Stop
Yeah,
sharing.
okay.
Perfect. Yeah. So I have just put the webinar attendee survey in the chat for everyone that's attended. I'll also send this by email, so no worries if you don't get it right away. And again, if you have any questions for our presenters, please feel free to post those in the chat or even in the Q&A.
I just want to say this was the fastest 50 minutes of all time.
It goes very fast.
I was really nervous about this, right? And now I'm not nervous at all. I wish it would end.
Well, see, and this like you could even have a follow-up webinar, maybe even sharing some of the information that you get from the attendees for this one even. So
heck yeah.
So I don't see anything. I'm gonna go ahead and stop sharing. And I'm not sharing. I'm gonna stop the recording. That's what I'm gonna do. All right.